Okay, again the warm welcome. The student who not join in the first session, first lecture, I will again warm welcome you on behalf of the college. Nothing but the T.Y.B.Sc chemistry. As I already discussed, the 5 papers are there. Okay, detail about the papers. Who will teach that paper that I already discussed. Now and then I again discuss the exam pattern, then how the possibilities and the probabilities are there, that also I talk in front of you. Then I discuss the syllabus of the analytical, 4 units are there, and I will send you the soft copy of that syllabus also, you have to write it. All the students, please keep your camera on, means that monitors how you are there or say not, that app is having that system. Then now we have to talk especially about the physical. This is again the another paper. This is the paper number 1 of this particular T.Y.B.Sc chemistry, which will taught by me. Just I am sharing the screen. Okay, you are visible this screen? Anybody can say the screen is visible?
Yes, sir.
Okay. See, again in the physical chemistry there are the 4 units. First unit is nothing but the molecular spectroscopy. Then the second unit is nothing but the case and the chemical kinetics. Third one is the nuclear chemistry, and fourth one is the surface chemistry along with the colloidal chemistry. These are the 4 units are there in the particular physical chemistry. First of all, we will talk about the syllabus of the unit 1 that we have to see in detail while the actual that particular course. In the molecular spectroscopy, as you generally know, the spectroscopy is nothing but the interaction of the light with the surface, or say you can call it as a material, or say anything. In the molecular spectroscopy, again there are the 4 types of the spectroscopy are there. Rotational spectroscopy, vibrational spectroscopy, vibrational rotational spectroscopy, and the 4th one is the Raman spectroscopy. The name itself indicates that first one is we have to study about the rotation, second one we have to study about the vibration, then combine rotation and the vibration, and the last one is the Raman spectroscopy. What is the difference between this spectroscopy? We will study in detail in respective particular that heading. Different region of the light are responsible for this spectrum, and whatever after the interaction of the light with the matter, they will give rise to the particular that what we can say the results, and that results will be in the form of the spectra, or it is called as a spectrum, that we have to discuss in detail. In the rotational spectroscopy, we have to talk about the dipole moment, then the polarization of the bond, then the bond moment, then the molecular structure, rotational spectrum of the diatomic molecule, that we have to see in detail. Diatomic molecule we have to see, that is a homonuclear diatomic molecule and the heteronuclear diatomic molecule, that you have studied in detail in the inorganic in the SY. Then we have to talk about the vibrational spectroscopy. In the vibrational spectroscopy, we have to talk about the degrees of the freedoms, modes of the vibration, then vibration spectrum. Then what is that is a simple harmonic oscillator, different energy levels, selection rule, 0-point energy. These are all then the nature of the spectrum that we have to see in detail in under this heading. Then the vibrational rotational spectroscopy, in that we have to talk about the different energy levels, nature of the spectrum, what are the P and R branches, then what is the anharmonic oscillator, that we will see in detail, and how that particular rotational vibrational spectra is useful in determination of the force constant. Then we have to see the IR spectra of the water and the carbon dioxide molecule. Then apart from these three spectroscopies, then the new mode of the spectroscopy come that you already know, C.V. Raman, who studied the spectroscopy, then that is nothing but a scattering of the electromagnetic radiation, and this is come under the Raman spectroscopy, and the spectra will result is called as a Raman spectrum. In that we have to talk about the Stokes line, anti-Stokes lines, then the Rayleigh's line, and we have to compare this IR spectra with the Raman spectra, then the rule of mutual exclusion that we have to see. Then next part is the second unit is nothing but the chemical thermodynamics. In the first the major weightage is there for the colligative properties, then the solution in the solids and osmotic pressure. And in the chemical kinetics only the CT is there. Last year in the SY we talk about this collision theory, just the assumptions that we have seen. Here the application of this collision theory is there, and then we have to classify the reaction based on their mechanism. We have to study the kinetics of this reaction, or say especially the fast reaction is there in your syllabus by the stop flow method and the flash photolysis method. In detail we will see during the lecture. Then nuclear chemistry. In the nuclear chemistry we have to study about the basic terms involved in the nuclear chemistry. Basic terms are nothing but a decay constant, half-life, average life, then the units of the radioactivity. Then how can detect and measure the nuclear radiation, also you can call it as a radioactivity. We have to discuss the different types of these particular radiations, then their characteristics, then behavior of this ion pair in the electric field, detection and measurement of the nuclear radiation using the GM counter and the scintillation counter that we have to see in detail. Then application of these radioisotopes as a tracers. In that we have to use this particular isotope as a tracer. Tracer is nothing but in the minimal amount for the study of the reaction mechanism, age determination by the dating by the carbon 14. Then nuclear reactions we have to see what are the nuclear transmutation reaction with the example, then the artificial radioactivity, key value of the nuclear reaction, threshold energy, fusion process that we have to see in detail under this nuclear chemistry. Then the last unit for this particular that physical chemistry for this semester, 5th semester, is nothing but the surface chemistry. In the surface chemistry we have to talk fully about the adsorption. It is a surface phenomena, and in the surface phenomena adsorption is there, not the absorption. Absorption is a different one and adsorption is a different one. Adsorption is nothing but the retain of the species at the surface only, and absorption is nothing but the any other species will get inside or say get in. There are the two types of the adsorption that probably we have to study, physical and the chemical adsorption. Then we have to talk about the adsorption isotherm, there are different types. Then Langmuir adsorption isotherm, its postulates and the derivation, bit equation that we have to see for the multi-layer adsorption. Derivation is not expected for that. Determination of the surface area of an adsorbent using the bit equation, numerical is there based on this. Next chapter, part is a colloidal chemistry, or so you can call it as a colloidal state also. For this colloidal state we have to talk about what are the colloids, emulsion, gels and the salts. You know, when you are using the surf powder or say any soap, at that time that particular that soap when dissolved in the water, at that time it gives the bubble. It is called as a micelle. Okay, it is called as a micelle. It is nothing but a colloidal particles. It is called as a colloidal particle. We have to talk about the electrical properties of this particular colloidal particles. Concept of the electrical double layer, Zeta potential, Helmholtz and the Stern model we have to see. Then the electrokinetic phenomena, in that we have to talk about the electrophoresis, electroosmosis, streaming potential, then the sedimentation potential, donor membrane equilibrium. These all phenomena that are the electrical properties that we have to study for these colloidal particles. Then what are the colloidal electrolyte? Colloidal electrolyte are nothing but the soaps, syrups. These are the colloidal electrolyte. And what is a micelle formation? That I already said to you, when we are dissolving the soap or the syrup in the water, at that time this gives the bubble, and that bubbles are nothing but a micelle. Then the surfactants, we have to see anionic, cationic surfactants, their example and their application in the detergent and the food industry. That part we have to see in detail. This is about the whole syllabus of this particular semester. Om Joshi,
Yes, sir.
I am Lakshya.